In this video, I'm going to talk about the CSF heat exchanger that I bought and give a quick review about it, do a full technical discussion and show all the data that I captured while using it this summer. I will put times at the beginning of the video so you can skip around to the information that's important to you. But long story short, for those that just kind of want an answer, yes, it helps, but no, it's not an end-all solution. If you're truly running into heat soak because of how hard you're pushing your turbo, eventually you're going to need an intercooler upgrade. So this is only kind of part of the system, and it does help keep temps down, but it won't completely eliminate heat soak if you are overwhelming the system. But chances are, if you're on stock turbo or even an upgraded turbo, you really don't have anything to worry about. So I'll talk about that coming up. For those that don't know, with the B58, the big change that BMW made is we don't have like a big air-to-air intercooler in the bumper, right? So your intake goes directly to your turbo, and then from your turbo, your charge pipe goes directly into the intake manifold. In the intake manifold, this whole section is an air-to-water intercooler. So the air is going through, getting cooled down, and then gets into the engine bay. So with this short piping, it makes it really responsive, and the air-to-water system is extremely efficient. Even on like a stage 1 or stage 2 off-the-shelf map, you really don't have any issues with cooling. At most, you need like a downpipe to optimize how the car is running, but nothing else is really needed. In my case, I'm on a custom stock turbo tune running ethanol, so I'm increasing how much the turbo is working and pushing it out of its efficiency range or higher in its efficiency range, which generates a lot more heat. And in my logs, I started noticing that the intake air temps were spiking. We have a lot of sensors on this engine that help us evaluate its efficiency. So right here in the charge pipe, we have a temperature sensor and a pressure sensor. And then coming out of the manifold right before the cylinder head, you have another sensor that measures both temperature and pressure. So if you have software, you can actually log that and see how efficient the intercooler is and how well it's working for your setup. So again, on my off-the-shelf maps, temperatures were pretty much steady, just flat. When I upgraded my tune, got the custom tune, I started seeing IATs increase. And so that's why I'm actually going to be installing the radiator to try to improve the efficiency of my intercooler. So when you see the intake air temps rising, that means that the coolant in your air-to-water intercooler is also rising in temperature. And that's a problem because while air-to-water intercoolers are very efficient and they're better at cooling because fluid transfers heat better than gas, you also have the downside that once it does heat soak, it's a lot more difficult to cool it down. So you really want to make sure it stays cool from the start and it doesn't get overwhelmed. And that's the problem that I'm running into. So you want to get this coolant to the front heat exchanger and cool it off as much as possible so that you can bring more cool coolant back to the intercooler and continue cooling down that air even as you're pushing the turbo harder and harder. Here I'm partially through removal of the heat exchanger, and I just wanted to show some more details about how our cooling system works. So you have two circuits, one for your engine that goes through this radiator in the back. It's considered your high temp circuit. And then you also have one that this front heat exchanger goes through. That's your low temp circuit that goes through the intercooler. And this one is the one that we're replacing. So since your engine can get up to, 220 degrees or even more in certain scenarios, they keep that coolant completely separate. And then the one for the intercooler only gets up to maybe like 120 or 130 tops, depending on your conditions. I guess if you're in hotter climates, it might get hotter, but definitely not as warm as the engine. So keeping it separate helps make sure you're not running hot engine coolant through the intercooler and making it less efficient. Up here you have two reservoirs. The big one is for your engine system. The small one is for your intercooler system. And then down here through the latch, that little cover that you see, that's your water pump for the intercooler. So basically what's happening when you drive the car is that the intercooler pump isn't running. The water in the system is just one giant heat sink. And then if you do a pull, like if you floor it or put it under high load really briefly, the water pump turns on and pushes a bunch of the cool fluid that's up here in the heat exchanger. It goes back into the intercooler, and you'll actually see your intake temps drop. And that's because you just got a surge of cold coolant going through there to help make that passing power really snappy, really powerful. You'll get all the torque on demand. However, if you're doing back-to-back pulls or track days, you're starting to pump coolant through there constantly, and it's easy to overwhelm the system. So that's where the gap is. That's why I'm upgrading the heat exchanger to get better intercooler efficiency when I'm pushing the car hard. So here we have the two heat exchangers side by side. Stock is on the left, CSF is on the right. I went with the black finish, but it does come in aluminum as well if you want it to be the original. And just looking at the thickness, CSF is about 2 1/4 versus stock is about 1 inch. So over double the thickness, and you can see the kind of strategy they use. This actual leading edge is the same. They just added additional thickness in the shroud area in the bumper. So that's how they get so much more cooling out of it. But we'll have to actually see with the data if it works better. Also, if you look at it from the front, you can see it's actually shorter. And that's because of the tube design that CSF used. They have little pinches inside of here that increases the surface area, so it doesn't actually need to be as tall to get more airflow. But you can see the stock one is also tube and fin, so it has really good airflow, and that's one of the reasons why it's so efficient. So getting like a cheaper bar and plate heat exchanger would actually probably reduce the effectiveness, so keep that in mind too when you're looking at the options. So the CSF one that I have is their version 2. The changes that they made on these end tanks, it's got like a taper into the main cavity that matches the OEM taper. Before, it just used to be like this inlet would go straight into there. So if you're looking for the differences between V1 and V2, or you want to make sure you get a V2, just look at the end tanks. That's the easiest way to tell the difference. And then it also comes with additional brackets. This is like mounting hardware for the transmission cooler. I won't need it because I have a manual trans, but if you do have the automatic trans with the extra cooler in the grill area, that allows you to mount it up just like OEM. And then there is also this rock guard. So I'm going to install that on the front just to protect it, because like I said, a lot of people have had issues with the stock heat exchanger getting nicked and draining coolant out. So those video clips were kind of bouncing back and forth, you know, before and during installation. Now this is after install. I've had it for thousands of miles, and I can give more of a long-term review. I ran it all summer, and, you know, I definitely noticed an improvement. My logging technique is to do a pull from about 40 miles an hour up to about 140 miles an hour, and just log how the temps increase and measure the delta before and after the intercooler. And I ended up doing a couple different changes. So the first thing, obviously, I installed the heat exchanger. I also put water wetter in the low temp circuit. You can kind of see there's like a reddish tint to the coolant now. That's the water wetter that I put in there. I put in a half bottle. And then I also removed the engine cover, and each of those actually netted some gains. So kind of in the order of cost, removing the engine cover is free. Adding water wetter to the intercooler circuit's like $10, and those will help. So if you want something that's really cheap, start there, see how your logs look, see if it improves anything. The next one that did have the biggest gain was the heat exchanger itself, but obviously it's significantly more expensive. The CSF one isn't so bad. I guess it's kind of in the middle of the range, but I went that route because of, you know, the tube technology being very similar in design to OEM versus going with like a cheaper bar and plate style that some of the manufacturers build with. So that's why I went with the CSF. It was basically the cheaper one that used the better designed, more efficient core. However, there are a couple different things to consider. The temps did drop. Typically doing a 40 to 140 pull, it went up like 20 degrees or more. After doing all of those changes, it dropped it to about maybe like 15 degrees. So I did see an improvement of about 5 degrees, but it doesn't give you like that flat temperature curve that you want. kind of what a lot of us were used to when we just ran stage 1, for example. If your turbo is only doing about 16 PSI, the heat exchanger keeps temps completely flat and you really don't see a move. And once you start pushing 18 plus on the stock turbo, you see it go out of its efficiency range and IATs rise significantly. So this helps, but it doesn't completely correct the issue. Really, it's just a result of running the turbo hotter and outside of its efficiency range. Another thing to consider, if it's not already obvious, is that these gains are only really realized if you have some sort of airflow going over the heat exchanger. So when you're doing road racing or roll racing, highway pulls, back-to-back pulls, that's where you see the biggest benefit of doing the heat exchanger upgrade. If you're doing drag racing, it's not going to give a significant improvement. Once you get going, it'll help temps stay as low as possible, but keeping the temps down between drag runs is going to be key. And my recommendation for something like that is to go into the intercooler circuit, take some of the coolant out and put ice in, put some ice on the actual intake manifold where the intercooler is, and keep the car running, keep the hood open so that all of that heat can get out of the engine bay. And that'll give you the best chance of getting low times when you're doing runs at the drag strip. So eventually, a lot of us are going to need to upgrade the actual intercooler in the intake manifold. There's just no way around it. In the hotter parts of the summer, this was especially nice. When temps were getting like 90, 100 plus Fahrenheit, it helped keep things in check. But the B58 can handle it. If you look at how your tune works, as temps rise, it actually adjusts boost and timing to keep things safe within the engine. So a lot of us are kind of reacting to hot temps the same way we would with our previous engines, but this ECU is actually extremely intelligent and can make those updates on the fly while you're doing a pull. So it'll make sure everything stays safe. And the only time I really saw the car going into a safety mode was when intake temps were above 140 degrees. So check your logs, see how things are running, work with your tuner to see what needs attention, and just make the appropriate changes. So at this point, I've had it. I said, the results weren't exactly what you wanted, but it does help. And people ask me, would I do it again? And I would. It's a part of a bigger plan for me because I do plan on upgrading the turbo and getting more power. So even if you update the intercooler in the intake manifold, you're going to want a heat exchanger to kind of complete it and make the full package. However, one thing I did do, I showed you guys I got the black one to make it more discreet. And this is how it looks after a couple thousand miles. So the rock guard's definitely working, but it just kind of looks crappy with all the paint chipping off. So it kind of is what it is, My car is lowered a lot and it's in an area where it's going to get beat up a lot. So it kind of sucks. If I did it again, I'd probably get the raw version, but you can kind of pick your poison on that one. And somebody said something that I thought was actually really funny. They said BMW on the M4 could have upgraded heat exchangers and done all kinds of things to improve cooling, but on their top M4 model, they added water injection instead. And that just tells you, if you really want to reduce temps in a system like this, the easiest way to do it is to add meth, add water injection, plumb it in somewhere after the turbo, and that will also help reduce your temperatures as well. So it's not something that I want to do. It requires, more maintenance, more plumbing throughout the car, and this is something that's like bolt-on and kind of OEM fit and finish. But if you really want to reduce your temps, meth is probably the more efficient option. So that's also something to consider. But for most people, if you're just running, a stage 1 or stage 2 tune, it's really not needed. It's not until you really start pushing 500 plus horsepower where you even start to experience heat soak with the stock turbo. And beyond that, even with upgraded turbos, you can run less boost and keep temperatures in check. So just work with your tuner, see what's needed, and react appropriately to your logs. Thanks for watching. If you have any questions or comments, leave them below.